Alright, today we're adding to our multi-step equations by solving equations with variables on both sides. We have a definition here of literal equation. A literal equation is an equation with two or more variables. So, what you want to do when you have variables on both sides is you want to get those variables on the same side. So what I always like to do is I always like to look at the variable with the constant, and I like to move it first, because usually this takes care of the problem of getting your variables on the same side. So 4x is being added to the 6, so we're going to subtract 4x from both sides. And that is going to cancel these 4x's out, bring our 6 straight down, and then x minus 4x, or 1 minus 4, equals negative 3. So we have negative 3x. Then we're going to divide both sides by the coefficient, which in this case is negative 3. These cancel, and you have a positive divided by a negative, so your answer is negative, and 6 divided by 3 is 2, so it's negative 2. So variables to the same side, divide by the coefficient on this one. This one's an easier one. Next one, not so easy. Okay, you got a whole bunch of stuff going on here. You got multiple variables on one side and a variable on the other side, and you got multiple constants. So because of that, the first thing we're going to look at is, can I combine any like terms? So I'm going to look at the left side, 10z minus 15 minus 4z. And I can combine 10z and minus 4z. 10 minus 4 is 6. Oops. 6, and our coefficient, or our variable, stays the same. I bring down my minus 15 equals, and now I look at the right side. And now I only have one term with a variable, so I'm going to look at the other two terms, and those are constants, so I can combine those. 8 minus 15 is negative 7. Okay? So now I'm at the point where I can move either a term with a variable or a term with a constant. It doesn't matter which you move first. They are going to have you move the variable term first, and that's what I like to do. I like to move the variables first. I like to try to move the variables all to the left side. So I like to take the variable on the right side, which in this case is negative 2z, and move it to the right side. So 2z is being subtracted, so the opposite of subtracting is adding. So we're going to add 2z to both sides. These cancel, and I have 6 plus 2, which is 8z. We bring our negative 15 down, equals negative 7. Okay, so now I'm to a two-step equation, so I look to the side with the variable and I look at the constant. The 15 is being subtracted, so I need to do the opposite and add 15 to both sides. That cancels my constants out. My 8z comes down, and negative 7 plus 15 is 8. Then I divide both sides by the coefficient, which is 8. These cancel, and z equals 1. Now, those are difficult problems. You just kind of gotta take it one step at a time. You cannot do everything at once. Combine your like terms on both sides. Then only move one term at a time. Either move a variable term or a constant to the other side, and then move the other. Do not do it in the same steps, okay? And then divide last. Some people are going to try to make that 1, 2, 3, 4, 5, 6-step problem. They're going to try and do it in 2 steps or 1 step. You're probably going to get the answer wrong, okay? If they're teaching you how to do something in 6 steps, it's probably because you need 6 steps to do it, so you should probably take the 6 steps. I need 6 steps to do it. I need to see my work and see what I'm doing, so if I don't get the right answer, I can go back and look through my work and see where I messed up, and if I only have it in 1 step, I'm not going to be able to do that. If you come up to me with your paper and I can't do this, and you only have one step, I'm going to give you the paper back and tell you when you have 5 or 6 steps, you come back and I will help you then. So, I probably sound really mean, but I was just getting after my boys for yelling while their baby sister was taking a nap because I didn't want them to wake her up. So I think that "da" is still in my voice. I really won't be mad at you. I'll just be like, yeah, right. Good luck. Don't come ask me for help yet. Daisy's Flowers sells a rose bouquet for $39.95 plus $2.95 for every rose. A competing florist sells a similar bouquet for $26 plus $4.50 for every rose. That's dumb. Find the number of roses that would make both florists' bouquets cost the same price. So we want them to be equal. So Daisy's Flowers, $39.95, I guess for the vase, plus $2.95 per rose. And we want that to equal the competing florist that charges, I guess, $26 for the vase plus $4.50 per rose. Okay? So, what we're going to do is we are going to subtract the variable from both sides. Doesn't really matter if you subtract $2.95 or $4.50. However, I like to subtract the smaller of the two because then it keeps me in a positive number, hopefully. So $2.95 is smaller, so we're going to subtract $2.95 in this case. So I don't have to deal with a negative number, hopefully. Okay? That cancels these. We bring our $39.95 down and our $26 down, and $4.50 minus $2.95 is $1.55. And we need to keep the R there. Now, I need to subtract my constant from my variable side, which is 26. It's positive right now, so that's why we're subtracting it. So that cancels these out. I bring my 155R down, and $39.95 minus 26 is $13.95. Now I need to divide both sides by the coefficient, which in this case is 1.55, to get the R by itself, and $13.95 divided by 1.55 is 9. So the services would be exactly the same if someone went in and bought 9 roses. It wouldn't matter which one you went to. Okay? If you were buying a bouquet with 9 roses, you would spend the same at either Daisy's Flowers or the competing flowers. So, next problem we got. Jamie spends the same amount of money each morning. On Sunday, he bought a newspaper for $1.25 and also bought 2 donuts. On Monday, he bought a newspaper for 50 cents and bought 5 donuts. He's obviously pretty hungry. On Tuesday, he spent the same amount of money and just bought donuts. How many donuts did he buy Tuesday? So, we need to find out the price of 1 donut in order to figure this out. So, on Sunday, he spent $1.25 plus 2 times whatever 1 donut costs. So that's where we get $1.25 plus 2 times D. Okay? And he spent the same amount on Monday, where he bought a newspaper for 50 cents plus 5 donuts for however much 1 donut costs. So this is Sunday, and this is Monday, and we want to set them equal to each other. So, in order to find out how much 1 donut costs, we have to solve for D. So we're going to subtract or move, but they're all positive, so we're going to end up subtracting a variable term. And remember, I said I like moving the smaller variable term if possible, so we can hopefully not deal with negative numbers. So I'm going to subtract 2D from both sides. So these cancel, and I bring my $1.25 down equals 50 cents, which I brought down. 5 minus 2 is 3D. So now I need to look at the variable side and move the constant. The constant is 50 cents is being added, so we're going to subtract 50 cents from both sides. Make sure that decimal's there. $1.25 minus 50 cents is 75 cents equals 3D. Because these canceled, right, and brought just our 3D down. Now we're going to divide both sides by the coefficient, which in this case is 3. So our 3's cancel, leaving us with one donut, and 0.75 divided by 3 is 25 cents. He obviously is getting Moose's loose donuts, huh? So the price of one donut is 0.25. Okay? Now we need to find the amount of money that Jamie spends each morning so that we can divide that by 25 cents and see how many donuts he bought. So, we need to choose one of the original expressions. We can either use 1.25 plus 2D, or we can use 0.5 plus 5D. They are going to use 1.25 plus 2D. Okay? And in for D, we're going to put the price of one donut. So 0.25. Now 2 times 0.25 is 0.50. And 125 plus 50 cents is $1.75. So Jamie spends $1.75 each morning. So if we know that each donut costs 0.25, we can find the number of donuts by dividing 1.75 divided by 0.25. So we're going to divide by the coefficient of 0.25, and we are going to get the number of donuts equaling 7. So Jamie bought 7 donuts on Tuesday. The equation t equals m plus 10e gives the test score t for a student who answers m multiple choice questions and e essay questions correctly. Oh my jeez. Okay, so this is the test score, and the test score equals the number of multiple choice questions they got right plus the points for their essay questions. Okay, so look at this. We want to know what E equals, all right? So in order to do that, we need to first solve for E. Since M is being added to 10E, we need to subtract M from both sides in order to start getting E by itself. That cancels our m's and our 10e comes straight down. Now t and m are not like terms, so it's t minus m. Okay, so now we have t minus m equals 10e. Well, e is still not by itself, but it's a coefficient and a variable. So e is being multiplied by 10, right? Because the variable is always multiplied by the coefficient. So we're going to divide by the coefficient, which is 10. T minus, oops, that's a minus sign. That doesn't look like a minus sign though, does it? There we go. One more. Okay. Minus m over 10. So we cancel those out, and that leaves us with just e. So e equals t minus m divided by 10. Okay? Alright, we were just solving that equation for e. I thought we had to find something out, but there you go. Let's see here. Let's do 1 and 2, and then you can pick between 3 and 4 for your check it out. You don't need to do both of those story problems because I don't want you taking the whole period to do those story problems and then I'm not getting anything on your lesson started. That would be a bummer, and I'm sorry this video was much longer, but it was a much longer lesson, and so that's just the way it goes sometimes.